possible. So worksheet 5, number 31. Is that the one you said, Allie? 31. Sine squared times secant squared over tangent squared. Anytime I'm stuck, I could put everything in terms of sines and cosines. So I think, you know what? I think the first thing I'll fix is the secant squared. So sine squared times 1 over cosine squared. And I think I'm going to leave tangent there. It's usually wise to make one change at a time. Otherwise, you can miss the answer. You can kind of blow right past it if you make too many changes at once. Well, look at the numerator. I have sine squared over cosine squared. What's that equal to? Sine over cosine? Especially look in the bottom and look at your answer choices. Tangent. Sine over cosine is tangent. So the top is tangent squared, and the bottom is tangent squared. So the answer is 1. What else from that worksheet? Let's do a few more.
Can you do us a worksheet 4?
Sure. Worksheet 4, number 27. Let's see, inverse secant. I don't want to do inverse secant. I'd rather do, what would you rather do? Let's do inverse cosine. The price you pay, though, is flipping it over. And then you have to fix it. So inverse cosine of root 3 over 2. 3 square roots of 3 over 6. Right? Because root 3 times root 3 is 3 times 2 is 6. And that probably fixed your problem right there, I guess. But let me finish it. Inverse cosine's got to come from 1 or 2. It's positive, so it'll be in quadrant 1. Root 3 over 2 is alongside. So the answer would be pi over 6.
Thank you.
You're welcome. Other questions from worksheet 5? Do some more of those. (27) Back on worksheet 5. And the instructions to that one kind of start on the previous page. Use a right triangle to find the value of each. So that's a bit of a hint that this isn't really a unit circle problem. Let's see. Arc tangent has to come from 1 or 4. It's negative, so it'll be in the 4th quadrant. Tangent is opposite over adjacent, or y over x, either one. So the y is 5, the x is 12. Why is it negative? Where did that negative come from? Which one of my values is negative? And why the 5? Yeah, the 5 is going down, so the 5 is negative. So again, we use the inside stuff to draw the picture. And then we use the cosecant, or the outside stuff, to...
5, 12, 13.
It is a 5, 12, 13. Again, if you don't remember that, then you've got to do the a squared plus b squared equals c squared. Let's see, cosecant is flip of sine. So h over o, or r over y, negative 13/5. Use the inside stuff to draw the picture, and then answer the question. But the restrictions are the important part. All right, 1 and 4 are inverse sine and his friends. 1 and 2, inverse cosine and his friends. That's the lesson in, well, that was Friday's lesson in one picture there. And then that continued into Monday's lesson as well. 1 through 21, all those unit circle ones, you good with? I mean, if you know your unit circle, you should be good with them.
Could you just do the Pythagorean identities, the cosine of the sine squared equals 1, and then change it into the other two?
Yes.
For a review.
Can you do
I will.
either 41 or 42 on page number 4?
41 or 42 on worksheet 4. Yes. So this is back on worksheet 4. The graph of Arctan is shown below. As x approaches infinity, so as x gets really big, so that means we're heading out this way, what value is y approaching? Well, so out here, out here, out here, out here, it's hard to tell, but it looks like y is approaching pi over 2. That would be as x approaches negative infinity, y approaches negative pi over 2. There's not really any work to show. Yep. Let's just look at the picture and see what's happening. What's that? I need to take out my magnifying glass and read that is pi over 2. 42? Well, look at the picture. As x approaches infinity, y is approaching 0. If we ask it on the other end, as x approaches negative infinity, y is approaching pi. Tyler, to your question on worksheet 5, let's do number 34. Because that's basically what you're asking, right? Which one of those do you absolutely know is true? This is the one you should memorize. A is for sure true. That's true, and that should be the only one you have to memorize. Sine squared plus cosine squared equals 1. That one's true. And then looking at the others, I don't know, because I find the others starting with this one. So let's divide by sine squared. That'll get us 1 of the others. So 1 plus cotangent squared equals cosecant squared. Okay, so C is, switch the order, but addition doesn't matter for the order. So C is good. So B or D, one of those isn't right. I don't know until I divide by cosine squared. Sine over cosine is tangent. Cosine over cosine is 1. And 1 over cosine is secant. So tangent squared plus 1 equals secant squared. So B is the false one. But again, the big deal is memorize the first one and know how to get to the other two, rather than memorize all those things and where's the plus 1, and don't worry about it. Memorize one of them and figure out the others.
There's going to be a lot of those on the test.
I mean, they're not worded like 34 where they're that straightforward, but you do use it a lot on the test, yes.
How will we know if it's a problem where we use the Pythagorean identities and is it going to be like a certain word? Is it going to be like simplify or something?
Good question. How do you know when to use the Pythagorean identities? Almost always, if a squared shows up, you're using a Pythagorean identity. No, I say almost always. Like 31, we did a couple minutes ago, that had a bunch of squares in it, but it wasn't a Pythagorean identity. Other questions from Worksheet 5?
Can you do 28, 29, and 30?
Sure. Let's do both of those, because 29 is a unit circle problem and 30 is not a unit circle problem. So let's do both of them. Inverse sine of negative root 2 over 2. Although you could treat it as a picture problem and draw opposite over hypotenuse, that would be fine, but inverse sine negative root 2 over 2, inverse sine's got to come from 1 or 4. It's negative, so it'll definitely be in quadrant 4. So what angle has a sine of root 2 over 2 in the fourth quadrant? Yeah, the one in the middle, the 45, the pi over 4, and we have to say it's negative pi over 4, not 7 pi over 4, because we got to get there the quick way. And then we want the secant of negative pi over 4. Secant is the flip of cosine. Cosine would be root 2 over 2, because it would be positive. It's
2 root 2.
And then we would need to flip that,
2 root 2.
and then we would need to fix it. So we got all sorts of stuff going on here, and 2's all over the place. So 2 root 2 over 2, which is just root 2. That's a good question. I had to write 2, 4, 6, 8, 10 times. 2's everywhere. But the flips and the fixes is what got us on the 2's there. Now, number 30, find an angle whose cosine is 2/3. Well, that's not a unit circle value, so I'm going to need to draw a picture for that one.
Wait, so how do you know if it's a unit circle value or not?
If you recognize it or not, basically, like root
Okay.
2 over 2 is like, wait a minute, that's one of those unit circle answers.
So 28 and 30 both aren't.
Okay.
2/3, that's not a unit circle answer.
So like on the test, you're not gonna be like, okay, draw a picture.
I don't remember if it says 2 or not, because this one says 2, but you don't need to.
Yeah. Okay.
So if we don't fully simplify that, is it completely wrong?
It won't be completely wrong. Like if you leave it as 2 over root 2, or even as 2 root 2 over 2, that's minus a point, because it's not simplified. Alright, cosine, or arc cosine, has to come from 1 or 2. This one's positive, so I know it's in the first quadrant. Cosine is adjacent over hypotenuse, or x over r. So 2 and 3. Is this a special right triangle where I know the missing side?
2, 3, 5.
It's the old 2, 3, 5.
Wait, is it not?
No. Well, even if that's not a right triangle.
Oh,
In fact, that's not even a triangle at all.
2, 2, 3.
The 2, 2, 3.
Isn't there one with 5?
There's one with 5.
3, 4, 5.
3, 4, 5. And this one, even if this was a 4 down here, this wouldn't be a 3, 4, 5 right triangle, because the 5 has to be the hypotenuse.
Yeah.
So how am I going to find the missing side?
A squared plus B squared.
A squared plus b squared equals c squared.
Square root of 5.
So b is the square root of 5. Okay, I almost celebrated too early there. We're not done. Cotangent is x over y. So 2 over square root 5. And then if we fix that, We get 2 root 5 over 5. Yeah. Anything else from worksheet 4? Did I mess something up? Kate, you good?
Yeah.
Okay. Anything else from worksheet 4? Some view stuff down there, 32, 33. Good with those? 33? 33 is a good one, because I don't recognize it right away. Let's see. Nothing squared yet, so no Pythagorean identities. Tangent sine over cosine, but that doesn't do much for me. I think if I distribute, though, it's one of those things where if you can do the next step in your head, you will know if it's a good step or not. If I distribute the tangent, tangent times tangent is tangent squared. What's tangent times cotangent? Boy, if you know this will make life a little easier on this problem. Well, if you don't know it, then we'll have to write it out. Tangent times cotangent. Tan and cotangent. How could I rewrite tangent, or how could I rewrite cotangent?
1.
Well, what's 1?
Cosine, cosine, cosine.
Okay, I could also do it that way. So ideally, you would recognize that tangent and cotangent are reciprocals, so when you multiply them, you get 1. That's the best way. If you do it a different way, that's fine. It's still going to work out. Sine over cosine, cosine over sine. Everything works out. So tangent squared plus 1 over cosine. Tangent squared plus 1, that looks like one of those Pythagorean identities, which we already have right down here. So the top is secant squared over cosine.
1.
So what should we do next?
Should be. What are you making? 1 over cosine?
So you want to replace secant squared with 1 over cosine squared? I think that's a good move.
When you have to multiply.
It'd be nice if your algebra skills are strong enough to do that. If they're not, then you do keep it, change it, flip it. So you end up with cosine cubed in the bottom, which isn't an answer choice, but it's pretty close to, or it's equal to, which one of those answers?
Secant.
Yeah, 1 over cosine is secant.
Wait, so could you have made it the bottom 1 over cosine?
You could have made the bottom 1 over secant.
Or,
Yeah, definitely. And looking back, that would have been a better move even. Secant squared over 1 over secant. If you keep it, change it, flip it on that, you end up with secant cubed. So yeah, that would have been a better way to go with this problem. Although we didn't really know that at the time. But that's a good example of, on these type problems, there's usually more than one way to get there.
Are we gonna have a lot of problems in the test where we have to like flip the identities around, like the 3 of them? It's like
Yes. Not a lot, but yes. The question was moving these identities around, and so recognizing, like which of the following is true or false. We could have had cosine squared equals 1 minus sine squared.
I thought in the top one, I thought sería 3
Right here,
Just like in the 1 over cosine squared.
this one.
Yeah.
So we keep the top,
Uh-huh.
we change the multiplication, and we flip the bottom. The bottom's cosine over 1, so we flip it to 1 over cosine.
So shouldn't it cancel?
No, because when we multiply, we just multiply across. 1 times 1 is 1. Cosine squared times cosine is cosine cubed.
Okay.
This is x squared over y divided by x. Keep it, change it, flip it. But yes, Tyler, back to your question. You will need to be able to move those around. I mean, that's just algebra adding and subtracting.
Yeah. So basically, like, when we're doing the identities, whenever we see, like, a 1, something could probably be done.
I wouldn't say if you see a 1, I would say if you see something squared. Then
1 and something squared.
Then yes, probably. Yes, if it's a 1 and something squared, it's probably one of those identities.